Hey guys, welcome back to my YouTube channel. So last class we have completed our discussion on the linear algebra. So linear algebra is nothing but how the input and output can be correlated. Like how we have also seen one of the example where how the classification problem will be taken with the help of linear dependent and linear independent vectors. So these are some kind of background things that we need to know. So continuing to that, so probability is that. So I will be letting you what are some fundamental terms and norms. So one or two lectures will be there. And for optimization, I will make it very quick because that is a completely algorithmic under the n-dimensional vector. So that is completely taken care by systems only and algorithms only. So if that is known, some kind of extension or some kind of basic things is known for us. So after that completing, we will be kick starting into our CNN, RN and those kind of models. Okay. So probability, which is nothing but framework for representing uncertainty. So we know that probability means it's uncertainty. So it is used to measure any kind of uncertainty in a system. Okay. So multiple sources of uncertainty there are happening. So thing is that inherent randomness in system. Some any kind of randomness in system. Inherent randomness. And then incomplete data or observability. Incomplete data or observability. Incomplete modeling. So in all of these things is we may need a probabilistic approach to get our defined or expected output. So if there is an incompleteness, the output may not be expected. So in this case, we need a probabilistic density variable with a dependence to another one variable. So this kind of probabilistic prediction which is needed. So which can state that the event of occurring something which may be dependent on some other event or which may not be dependent on some other event. So these kind of diplomatic approaches we need to get into understanding. So even weather prediction model that we are creating, right? So that thing will also be a good probabilistic approach only. So there is two type of principles that we can make into implementation. One is construction learning system. Construction learning system. Second thing is the analyzing learning system. So the construction of learning system is not our in hand. Those things will be taken care by engineers who are working at backends or who are making the preparing or training the models. So our thing is analyzing, even not analyzing. So we are at a point of using the things only. So both will be relying on probabilistic models only. So whatever maybe our usage or even training or any kind of things will be coming into probabilistic models. So the power of probability is not that simple that with the help of probabilities, the estimated uncertainty finding is very much good in results. So even in our communication system, we will be mainly focusing on these kind of things. So there is one quite difference or terminology difference, which is frequentist versus Bayesians. So we can use any kind of approaches in here. So in frequentist is depends on proposition of event in indefinite sample set, which is nothing but objective measure, which is objective measure. But in case of Bayesian, the measures degree of belief, which is subjective, not objective, which is purely based on probabilistic event. So in most of the cases, we will follow Bayesian kind of things for our analysis algorithms. So while solving those things, we will be coming into those picture. So now we have saw why probability is needed and what's the important thing that we needed. So let's see some kind of basic definition and notations which is followed in probabilities. So we know the random experiment, which is any kind of event that is happening without an assurance that this or this may happen. So that is what random event. So what are the possible outcomes from the random event, which is named as sample space? These kind of sample space can be determined as S, which is equal to R plus. So any kind of variable. For an example, that may be X where x is greater than 0. So these are some kind of sample representation that we can make it. So this is how the probabilistic notations that can be taken into picture. So random variable. So random variable is nothing but a event or a outcome that is mapped to the real axis. So if it is a single variable or a single thing map notation, then we call it as a random variable. The useful notation donate outcome of random experiment by number. The thing is that it donate or outcome of random experiment RE by numbers. Okay, so any kind of mapping, this is purely based on mapping. That is not our thing. So for an example, if a probability event of R which is greater than 10, if they are asking us to find out, then this R is a random experiment outcome. There, what are the possible outcomes that is coming above that can be mapped to a real number that we can take into our observation of answer. So that is how the random experiment will be mapped to the real axis in order to see observations. So these are a few kind of notations that we have in probability events. So probability distribution, so which is one of the important thing where we will physically or significant physical significance behind it can be understood. Probability distribution, which will be some graph kind of representation behind that. Probability distributions. Okay. So there is two kind of probability distribution or two kind of random events, which is discrete random variable and continuous random variable. Okay. So even some case mixed random variables are there, but that is not our region of interest, so we can skip it. So discrete random variable has a countable range. Okay, so the basic unit for measurements, which is PMF, which is probabilistic mass function, but in continuous event that is PDF, that is probabilistic density function. Then from the probability density function, we will be able to obtain CDF, that is a cumulative distributive function. That is another one kind of representation that we will following. But these kind of small terminologies are not needed in our duration of courses, because the probability, which is the key term that is relying between the models in order to predict the output. So these kind of small understanding if you guys have, then that itself will be fine for us to proceed further. For now, just we are going and noting out all the notations and what are the different types of units of things that are available. So these are some kind of small notations how we have come across a linear algebra. Similar to that, we are seeing small notations and basic terminology behind it. So let's see some kind of dependent variable that are available in the probability density function. That we know that the probability output may not be always depend on one kind of things. There is many things that will be dependent on those things. That is joint probability is one kind of thing. Many things is there. So let's first see about joint probability. If you guys know about these kind of basic terminologies, you can skip it, no worries. So joint probability is the condition where the output will be relying on the dependence with another one thing. Like for an example, if a bucket has 2 to 3 variable, 2 to 3 things, then the outcome of one will be depend on another one also. Similar to that, but the definition is not simple. The probability that x will take the value of x small x and y will take the value of small y. For an example, this is the probability given when x which depends on small x and y which is depend on small y. The two different random events that is possibly contributing to a randomness in this thing. So that is what we will be calling that as a joint probability distributive function. So these I am not going into depth of these kind of definitions. So these kind of small definitions and terminologies only I am pointing out, because that itself will be fine for now to proceed. Next is conditional probability. So this is what the first definition I said, right? The dependence or correlation factor. So conditional probability. So here the definition is y which is dependent with the pipe symbol of x which is equal to x. So this can be the complete dependence of y when x is occurring. This only when this event is occurring, then only this event will be contributed. So the formula behind it to find out all these things is that we can come across later. So that is not in our needed of ring. But for now I can represent the simple thing that it will be purely depend on that y which is equal to y comma x which is equal to small x divided by the intersection event of y and x. So like this way we can depend. But these values will vary and these formulas will be vary based upon different conditions based on dependent independent vector. So those kind of things just will be coming into picture when we go deeper into this kind of concept. But for now this definition is far enough. So let's go into Bayes theorem. So which is one of the very important theorem that is used to find out the dependency probabilities. So when y of x which is occurring, then the value which will be focusing on the probability conditional probability of x occurring when y and the probability of y divided by probability of x. So this is the Bayesian formula that it is given from the product and sum rule. So just remember this formula. These are some kind of background theories that are coming into picture and given by different scientists. So these are some small kind of algorithmic and probabilistic approaches that are already implementing in the models. So we already seen, right, the hidden nodes and the layers which all are formed by these kind of things. So the output from all these nodes and hidden things will be calculated based upon these kind of things. Like in Bayes theorem we have two kind of things like is likelihood, prior and posterior. So we already know many kind of detectors are there in wireless system. That is likelihood detector, maximum the ML detector, maximum likelihood detector, right? Similar to that, we can also state some things. So the probability of y under the condition of x, the event is occurring, will be directly proportional to probability of x when occurrence of y with probability of y. Okay. So this is posterior probability. So some naming that they are giving. This is posterior. This is likelihood. Okay. And this is prior. Okay, the posterior will be directly proportional to the product of likelihood and prior. So this is what the basis that the scientists coming into picture and saying that. So even if you guys not getting these points, you can skip it, or if you guys need more curiosity, then please comment in the comment section. I will be guiding you with some kind of articles where you guys can able to understand very many things about probability and the variations. So I hope this will be very much good for you guys to prepare with the probability. For now, you need to know about how the probabilities and the density or the probability vector output are able to predict the outputs. That I last class, the diagram I detailedly said that. So from next class, let's start with optimization. That is our last topic in our mathematics. So after completing that, we will be kickstarting our CNN, RNN and deeper into ML and DL. So I hope you guys able to understand some kind of basic things. Yes, even if you guys not able to understand, please comment in the comment section. I will be giving you or guiding you some kind of videos on that. Okay, thank you. Like, share and subscribe the channel. Stay tuned guys.